In this video, we're going to be discussing the Pythagorean Theorem and doing some examples with it. So the Pythagorean Theorem is very well known, and it is a squared plus b squared equals c squared. And it has many applications, but the application that we're going to do is basically the most general solving right triangles. And we're going to be discussing the lengths of the sides. So in a right triangle, the two sides that form the 90-degree angle, so the intersection is going to be this 90-degree or right angle. Those are going to be our legs, and we can call them A and B, and it doesn't matter which one's A and which one's B. They're interchangeable. The side that's going to be opposite this 90-degree angle, or the right angle, will always be the C side, or we call that the hypotenuse. So the relationship here is whenever we square both of the legs and add them together, that's going to be the square of the length of the hypotenuse. So let's go ahead and do this first example that I have. I have a right triangle. We have the two leg values, which are 4 and 3. So we're going to start with a squared plus b squared equals c squared. And I'll call this leg A and this leg B. And the missing side is going to be C. That's the hypotenuse. We're looking for that. So the value of A will be 4. So when I plug this 4 in for A, I'm going to put it in parentheses. And then my b value will be 3, so I'll also substitute that in using parentheses. And this c squared value, or the c, is the one that we're looking for, so it's unknown. So let's go to the next step. 4 squared will be 16, plus 3 squared will be 9, and that equals c squared. So when we add this up, 16 plus 9 will be 25 equals c squared. So here's the step that's going to be a little tricky, but that's very important to do right every time. So we have 25 equals c squared. We don't want it to be c squared, we just want it to be c. So in order to do that, we're going to take the square root of both sides, because this square root right here and this squared will cancel each other out and leave us with just the c. And the square root of 25 will be 5. So in this case, our value of c, or the hypotenuse, is going to be 5 units. So we could say c equals 5 right there. Okay, we have another example now where in this case we're given the length of the hypotenuse and we're given one of the legs, so we'll be searching for the other leg. So I've labeled this other leg B, which means this leg will have to be A, and this 13 here will be our C. Okay, so we'll start again with a squared plus b squared equals c squared. Our value of a will be 5, so I'm going to substitute that in, and always use parentheses when you substitute values. Your b value you don't have, that's what you're looking for, so we can just leave this as b squared. And our c squared, our c value will be 13, so I'll substitute that 13 in for c, and put it in parentheses when I substitute values, and put the squared there. So now let's go ahead and simplify. So 5 squared is 25, plus b squared, and 13 squared is 169. Now I'm solving for this b squared right there, so in order to isolate it on that left side, I need to subtract 25 from both sides. And when I do that, I'll have b squared equals, and then 169 minus 25 will be 144. So once again, as we saw in the previous example, when we have b squared, we just want it to be b, so we're going to take the square root of both sides. And the square root here with that 2, or with the squared, will cancel, so you just have b. And the square root of 144 will be 12. So that b side, or the length of that other leg, is 12. The next example I want to look at is a right triangle whose sides are 5 and b, because we don't know this other leg, and whose hypotenuse is 10. So again, the hypotenuse is the side opposite the right angle, which is always the longest side, so he'll always be the c value. Okay, well, no different than before. We're going to start with a squared plus b squared equals c squared, because we're dealing with a right triangle. Okay, and let's put in our values. A and B are going to be the legs, and B right here is already our unknown, so I'll just stick with our B right there. And it looks like our A value is going to be our 5, so I'll put 5 squared, and put that in for our b. And in this case, the c we do know is 10, so I'm going to substitute 10 in for c and square that. Okay, so when I square both of these, 5 squared is 25, plus b squared equals 10 squared, which is 10 times 10, which is 100. Okay, so I know that 25 plus b squared equals 100, but I'm solving for b, so I need to subtract 25 from both sides in order to get that b by itself. So these 25s will cancel, and I'm going to have b squared equals 75. I'm going to move this up a little bit. Well, my b squared is 75, but not just b, so I need to take the square root of both sides in order to have this square root, or this radical, and this squared cancel and give us just b. So b is the square root of 75, but as we did in the previous videos where we did simplifying radicals, I need to simplify this radical because 75 can be reduced. And I'm going to find the prime factorization of 75 first. I know that 5 will go into there to give me 15. I know 5 will go in there again to give me 3. And 3 will go in to give me 1. So I know that b is going to equal the square root of 3 times 5 times 5. And I have a pair of 5s here, so the pair of 5s are going to come out, and my value for b is going to be 5 times the square root of 3. So whenever I started with my right triangle up here that had 5 as one leg and b is the other leg and 10 is the hypotenuse, I know that my b value is going to be 5 times the square root of 3 for my final value on that length. Okay, let's go tackle another problem. So right here I have a right triangle. I have a, that's my missing value. My other leg is going to be 3, so I know that's going to be my b value. And again, the side opposite the right angle is always the hypotenuse, which is the longest side, which will always be given as c. So a squared plus b squared equals c squared. My a value is unknown, so I just leave it as a. My b value is 3, so I'm going to take 3 squared. And my c value is 3 times the square root of 2 squared. Okay, so to this point we've not seen a square root as one of our sides, or square root as a part of the expression that is the length of the side. So how are we going to square that? Well, the square, since things are being multiplied, these 3's being multiplied by the radical 2, the squared is going to distribute as to both of those. So it'll be 3 squared and the square root of 2 squared. Well, whenever you have a square and a square root, these two things are going to cancel, and the square root of 2 squared is just 2. And then 3 squared is going to be 9, and 9 times 2 is going to be 18. Another way to look at that is if you have a number on the outside, actually just go ahead and square that. So 3 squared is 9, and then multiply it by what's in the square root. So 9 times 2 is 18. So that's probably a little easier way to look at that. And my left side is a squared plus, and 3 squared is 9, so I'll just bring that down right there. Okay, and then in order to solve for this a squared, I'm going to subtract 9 from both sides. I'll move that up a little bit. So I know my a squared, those 9's cancel, so my a squared is going to be 9. And when I do the square root of both sides, I'm going to get my a equals 3.